This is the PCB of a Gree 1.5-ton outdoor unit. Now, let's see what the problem is. The PCB is functioning, but it's also giving an E6 error. So I will check what the situation is. I have already installed the reactor, and you can see that I have connected the electricity. I have installed a multimeter to monitor the electricity supply. Now, when we supply electricity to it, we can see 229 volt on multimeter, and the two LEDs have started blinking. As you can see, both are blinking, which means that the unit is in a hung state. The PCB has become unresponsive and is not functioning at all. These lights will continue to blink regardless of how many hours you leave it connected. Now, we will check this entire PCB properly because we need to determine where the fault is. Let's start the testing. We can see that there are two line filters installed here. We will check both line filters one by one to see how many volts we are getting. As you can see, we are getting 228 volts, which is perfectly fine. Now let's check the output of both filters, because if one has an output, the other should also be fine, and both are indeed fine. In these PCBs, there are two types of rectification used. One rectification goes to the compressor, and the other rectifier is for the SMPS. So we will also check for the SMPS here. Let's see how much voltages are coming at AC terminals. It's perfectly fine. Now we will check the DC voltages and switch the meter to DC voltage. When we did that, we are getting 314 volts, which is absolutely fine. The low side is perfectly fine, but there is a problem with the high side, and the microcontroller is functioning well, but the controls ahead are not working. So let's remove the electricity and check why it is in this position. Now, I have removed the PCB from the cover, and after taking it out, I found several things that indicate why this problem is occurring. When I physically inspected it, I noticed that the capacitors are swollen and damaged. They are bulging and not flat anymore. There are now 3 problems present, so let's check the other 2 problems. First, we'll look at the high side to see why the voltages aren't coming through. The capacitors are one reason, and the second reason could be the bridge rectifier. So let's check it. We will check it in diode mode, and as you can see, the second diodes have short-circuited. That's why it is showing value of 0. Now, looking further, this diode is also completely shorted. However, the advantage is that it hasn't affected anything downstream. The IGBT is safe, and the IPM is also safe. Let's test the IPM and see the voltage appears and disappears. The next point is also fine, and there's nothing beyond that. And the last one is also okay. Polarity changed, and voltage appeared here and then further along. And the last one is also okay. So both the IGBT and IPM are fine, but this diode rectifier and these capacitors are damaged. I will change them and check if everything gets okay. Now I have removed 2 capacitors from here very carefully. Now I'll remove this capacitor in front of you to show you how easily it can be done. I haven't cleaned anything yet. I'll remove it without cleaning, but pay close attention to the trick and try it yourself. You'll really like it. As you can see, there's silicone applied to it, and if the silicone isn't removed, it won't come off easily. Here's what you need to do. Press a hot soldering iron against it and add more solder. When you add more solder, the silicone will melt away, making it easy to remove. You can take it out directly, but it's better to clean it first for a smoother process. If you have a knife-tip soldering iron, that's even better because it generates more heat. Make sure to add a generous amount of solder. If there's not enough, it won't come out easily. The more solder you add, the easier it will be to remove. I've added solder, and the heat has reached down. When I moved it from below, it started coming out. Now I'll do the same with the other one, and as you can see, it has came out easily. Now we will clean it. You can use a soldering iron directly or a solder sucker. As you can see, it cleans up easily. I have now replaced the components here. So as you can see, the diode, rectifier, and capacitors are all fixed. Now let's check if this PCB is fixed or still faulty. Comment and let me know if you think it's fixed or not. After changing everything and ensuring they were fixed, it still hasn't worked. I'll show you what I changed. Let's check the diode and rectifier again. Checking the rectifier, it's showing 0, which means it's short-circuited. Now let's check the diode. This common point should be short, but the anode and cathode shouldn't be short. As you can see, this is also showing 0, meaning both are short. I had also changed these capacitors because they were damaged, but the problem still hasn't been resolved. Now this circuit has been fixed, and its blinking has completely changed. So as you can see, I'm supplying electricity, and the lights have started functioning again. However, the blinking pattern of the lights has changed. Before, they were constantly on, but now they will change after a while. Let me show you. After a little while, it has gone to a single blink. Along with that, the green light is stable now. then it turned off, then double blinked. You can see it has returned to a single blink, and then the green light turns on again. So now it seems to be trying to communicate something, but since there are no sensors installed on it, that's why it's behaving this way. Next, we will check it inside the unit. As you can see, I have installed the PCB back into the unit, and the outdoor fan is running. The compressor has also started, and you can see the amperage starting to increase. The cooling will also begin shortly. Currently, the unit is drawing 3.93 amperes, and the cooling in the pipes has started to function well. This means that the PCB is working perfectly. I have shown you that this PCB is completely fine and has been installed back into the unit. However, I have another PCB of the same model, and I will provide some information that I didn't mention at the beginning. This PCB does not supply electricity directly to the IPM and rectifier. Its switching system does not work directly. The low side has its own SMPS and a separate rectifier system for electricity. That's why its microcontroller and the rest of the system start working. When both units are connected to each other, it begins to function. After a few seconds, the two units connect and start communicating with each other, and that's when its switching occurs. I will also explain how that works. This unit has a double-stage switching system. First, switching occurs through this blue relay, which then sends power to the rectification stage. The microcontroller then tests all high-side components, and once it completes this test, the main switching happens, which is enough to handle the compressor load. After this, the relay switches. Anyone repairing this unit should not try to bypass this switch directly. If it's faulty, you won't hear the switching sound as I explained. Instead, two lights will keep blinking continuously, and when it's functioning properly, the lights will change. Now, I'll share another point I haven't mentioned yet. The other PCB I installed earlier was not working correctly and wouldn't turn on. I recorded a video of that as well, so let's take a look. So as you can see, when I checked it initially, it wasn't working. But when I rechecked it, I found that capacitor C82 was also swollen, which means it was also faulty, and the SMPS wasn't functioning either. I will replace this capacitor as well and see if it fixes the issue. Now you can see that I've replaced the capacitor and the unit is now working perfectly. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.